Hello, in the previous video we discussed about chemical bond, types of chemical bond, electrovalent bond, covalent bond, coordinate bond, single bond, double bond and triple bond. In this video I will discuss about hybridization, which is the basics which is the important basics for the VSEPR theory, valence shell electron pair repulsion theory. So I will define hybridization in just few words, which are it is just mixing of atomic orbitals of different energy level to form hybrid orbitals of same energy level. What are atomic orbital and what are hybrid orbital? I will explain. For example, we all have learned about S subshell which have one orbital and spherical in shape, P subshell which have three orbitals, and D subshell which have five orbitals. So these are simply atomic orbitals and these are of different energy level. Different energy level. So for example, so hybridization is nothing, it is just mixing of atomic orbital. For example, if we mix one s or atomic orbital with three p atomic orbital, both are having different energy level. If we mix them together, they will hybridize in order to form four hybrid orbital which are of same energy level. Since they are formed by the mixing of 1s and 3p, so they all will be having name sp3 hybrid orbital, sp3 hybrid orbital. So it is just simply we can define hybridization it is just mixing of atomic orbitals of different energy level to form hybrid orbital of same energy level. After hybridization, the number of orbital remains same. What it says, for example, here we have mixed the four orbitals with each other, means one s atomic orbital and 3p atomic orbital, total four atomic orbital. And after hybridization, the orbital number of orbital was also 4, so the number of orbital always remain same. All hybrid orbital are of same energy. After hybridization, their energy of atomic orbital redistributes and forms hybrid orbital of same energy level. They are responsible for sigma bond only. This is the most important term. I will explain later in the videos what are sigma bond and pi bond. So this is not required for the VSEPR theory. I will explain it later in the chapter. We just simply learn this word that they are responsible for sigma bond only. Now we will head towards the type of hybridization, which are sp hybridization. We can define sp hybridization when one s orbital and one p orbital combines in order to form two hybrid orbital. Again we can see that there is combination of one s and one p, means total two atomic orbitals in order to form two hybrid orbital. How they combine we can see. For example, it is s orbital and there is one p orbital. If they combines, they will form hybrid orbital, two hybrid orbital of same energy level. If since there is combination of one s and one p, so the name of the hybrid orbital will be sp hybrid orbital, and this will also have name sp hybrid orbital. Now we can see example of sp hybrid orbital is BeCl2. We will discuss it in VSEPR theory in detail. Sp2 hybridization. Sp2 hybridization is nothing, it is also just mixing of 1s and 2p type of atomic orbital. How? 1s and 2p type of atomic orbital which are of different energy level, they will mix with each other in order to form three hybrid orbital of same energy level, and each of them having name sp2 hybrid orbital. And if we see The example of this is BCl3, that is boron trichloride. Next type is Sp3 hybridization. Sp3 hybridization, it is just intermixing of 1s and 3p type of atomic orbitals to form 4 sp3 hybrid orbital. If, for example, CH4, CCl4, we can take many example, NS3, H2O. In similar way, we can define the rest hybridization like sp3d and sp3d2. In case of sp3d, there will be intermixing of 1s, 3p and 1d atomic orbital, and in case of sp3d2, there will be mixing of 1s, 3p and 2d atomic orbitals. For the example of sp3d, we can take example of pcl5, we can take example of PCl5 ClF3 as example for the sp3d, and for the sp3d2 we can take example SF6 and xenon tetrafluoride. Now I will discuss valential electron pair repulsion theory. Before discussing about valential electron pair repulsion theory, I need to discuss some basic terms about which will be responsible for the explanation of that theory, which are central atom. What is central atom? The atom which is least in number. For example, in case of CH4, carbon is least in number, so this will be acting as a central atom. In case of CCl4, carbon will be central atom. In case of NH3, nitrogen will be central atom. So we can take many examples. Valence shell, the last cell present in any atom. For example, if we write the electronic configuration of carbon, which is 1s2, 2s2, 2p2. So the last cell in carbon is second shell, and the number of electron in these cell are valence shell electrons. So total there are 4 valence shell electrons. For example, we can also take beryllium, which have electronic configuration 1s2, 2s2. So the last cell is second cell, and the number of electron in the second cell are 2. So the valence shell electron will be 2 in case of beryllium. So this is about valence shell. Third one is bonded atom. The atom which is bonded to central atom. For example, we can take NS3. So since nitrogen is least in number, so it will be central atom. Hydrogen, it is bonded to central atom, so it will be our bonded atom. The next term is bond pair, number of bonded atom to the central atom. Electron pair, half of the sum of the number of electron in valence shell and electron from bonded atom. I will discuss this formula in detail in the valence shell electron pair repulsion theory. And the last term is lone pair, which is equals to the electron pair minus bond pair. Hope you all have cleared about hybridization, which is just intermixing of atomic orbitals, and type of hybridization: sp, sp2, sp3, sp3d, sp3d2 and so on, and some basic terms which will be used in the valence shell electron pair repulsion theory, which are central atom, valence shell, bonded atom, bond pair, electron pair, lone pair.